Hey, what's going on, everybody? Today is April 23rd, 2024, and you're listening and watching the Daily AI Show live. And today, if you can see our screen, it's all about decoding some AI jargon, some terms, some acronyms. You know, what is in a name? We've got Junmi, Andy, Robert, and I'm Brian. And, you know, we're going to throw out some terms that we think are important and explain why it's important to know what they mean in terms of business value. But we would also love it if you're listening here live to, you know, throw any questions or comments in, you know, ask us about a term. We'll certainly give our take on it. So if you have suggestions or you have thoughts or comments along the way or questions, feel free to throw that into the chat, either on, you know, our YouTube or LinkedIn Live. And we will certainly do our best to bring them into the conversation. So we were talking right before we went live and we were like, okay, how do we want to organize this? And what we're going to do our best to do is, number one, not just throw out rapid fire 150 terms. You know, there's Google for that. What we want to do is put a little bit more meaning and understanding behind some of these terms. Also, though, for the sake of keeping things more streamlined, we're going to try our best to start with some of the more simplistic terms, basic terms, and move throughout the course of the next 30-ish minutes of the show towards some of the more complex terms. So that's the goal for today, is to just sort of go there. And I don't know, guys, if there's like, you know, do we want to start as like, you know, a definition of AI? And I don't mean that like as a throwaway. The reality is, I think AI and things like LLMs and even things like machine learning, if I go back to like 2017, when I was working in the business intelligence space, machine learning was the term that everybody wanted to use on their website. Today, it might be chat or an LLM or something like that. So I think some of these sort of more basic terms get confused sometimes. I don't know, Andy, Robert, I guess, Robert, you got something to show here.
Yeah.
So why don't you start us off here? Oh, yeah, I like these slides that you did.
Yeah, so shameless plug. This is one of the slides from a presentation I do when I do workshops. Yeah. And I love this because I kind of stole the idea from a workshop that I had attended. But if you look at the terminology of AI and you hear it constantly in 60 Minutes and in YouTube videos, and everybody, they use the two letters too much. And so AI is like saying, I eat food. And it's like food is too generic of a term. Like I like, you know, Asian food. That's still too generic. Like I like noodles. Okay, they're getting better. So we're looking at, if you look at the terminology, to start on the biggest sphere being artificial intelligence. And so that's basically making computers so that they think and act the way that humans do, or process like humans do. That's the goal. AI has been around for 60, 70 years. So it's nothing new in that scope. Then you go down one layer and it's machine learning. Algorithms that get better the more data they see, right? Then there's deep learning. And then inside of deep learning, you have generative AI. And even inside of that, you also have large language models. So when you think of that as the context of what most of the time we're talking about on this show is in the deep learning sphere. Sometimes you'll have the robots, which uses deep learning, but it's machine learning as well. So I think most of where people are excited with ChatGPT, the Anthropics of the world, we're really in the subset of deep learning, which is the large language models, the conversational AI, generative AI. Those are what we're mostly talking about these days. I think this is a good way to categorize those terms. And now obviously there's generic terms, but how they relate to each other is important.
That's super helpful. And if you're just listening to us, I highly recommend, you know, going over to YouTube or Spotify and you can actually see the video on this, because what Robert shared is a really nice graph, or I would say, like almost like an infographic of the circles within the circles, and like he was explaining, breaking it down. So highly recommend going back and doing that. That was awesome. That's a great start to this. So, okay. So you're right. Like I say this oftentimes too, if you go onto LinkedIn and you search for jobs and you put in AI today, like as of April 23rd, more than likely you're going to see like machine learning coding jobs still. Right? That's the AI jobs are more likely. They're looking for people who understand how to write code, how to build models. These are engineer type jobs a lot of times. Mm-hmm. In the future, I don't know if that balance will tip totally, but you will see more like what you were just talking about, Robert, I think, which is in the deep learning side, that even if we go deeper than that, the generative AI side of things, where you're going to have people hiring and saying, we need people with really good communication skills, and we need you to be able to deploy new, let's say, custom GPTs or something like that, and understand how to write the language, to get the best result out of it, or to train our internal employees, or whatever the case is. You might work in training or something. So we don't really see that as much today, but I think it's worth pointing out that, I don't know, I'll take your guys' opinion on it too, but I definitely see more of the still coding side of it, like the engineer side of AI, and not as much, in the generative AI as of today.
Yeah,
Well,
I have to agree. I think we're going to see that for a while, mainly because there's a recognized shallow end of the talent pool currently. So as we ramp up and get AI integrated into just more use or more companies and systems, then what we're going to see that trend for a while.
and
But I'm hoping it'll get to to the other side of things pretty soon.
But I mean, I know we're getting a little off topic, but I think it's important to follow up on that and say that the bigger problem, I think, is that they're not quite expertise in those new lanes. This is a new horizon, a new what do you call uncharted territory of jobs. Nobody's coming out of school with the degrees necessary to have a hire for a chief AI officer or even an AI DevOps person. It's a little bit nebulous right now. They haven't quite determined what that person's doing, and even the companies aren't even sure what they're supposed to have. And we consult all the time for companies. They're like, what should we be doing? We heard AI is a big deal. What does that mean? Like, they have no idea how. So how would they hire somebody? They wouldn't know. So they're hiring to something that they've got no knowledge of. So there is no job descriptions out there yet, because there's no people with those skill sets yet, or they're slowly developing it as we're learning here.
And I was just going to say that real quick, Robert, like the same thing you were just saying with jobs. Go look at a current, I'll say, US based university syllabus on AI, because God knows the universities are totally kind of trying to cash in on AI, totally, right? But they need to create a syllabus. You need to create a course. What are you going to create a course about in generative AI necessarily if they don't necessarily? And what you'll see is that, once again, they want to teach the students maybe the engineering side of it. And that's fine. That's certainly one way to go, right? But that's not all there will be in the future. And I think I wouldn't be surprised if some students are getting a little misled with something that's big, bold, and shiny and says AI in the course title, but is taking them down perhaps a different path.
Yeah, I can show you the course rubrics for the University of Tennessee, the new degree they're launching in fall, and it's it is kind of like building the ship as you're sailing it, so to speak. A lot of these courses are on the generic premises of what they're going to be offering, but honestly, this is going to change in the fall and in October. It's going to be modified, but that's okay. That's the purpose of that course. But to get us back on topic, a couple of the terms that when I was first learning about AI, maybe Andy can jump in because he's the brains of our operation. It's the terms that kept on. I was hitting a brick wall. I was trying to read papers, or more importantly, listen to people explain papers on YouTube. There's a guy I follow that does a great job of it. And it's the RNNs and transformers, and maybe those in the listening might want to know more about those basic concepts, because the transformer architecture, but came out in 2017, which is attention is all you need paper. That is really what was the foundation of what we know today as large language models. And so maybe understanding what transformer means and how it differs from recurrent neural networks, RNNs, that were previously the technology behind machine learning or language models. So maybe you want to share a little bit about your knowledge on that, Andy, if you have any.
Yeah, so let me follow the very nice drill down that you starting with AI to ML to DL, which is deep learning. So deep learning is that subset that's using deep neural networks. So that's another term of art here, neural networks, using those to accomplish some of the computing tasks that we're interested in. So deep learning and deep neural networks are a general class that include transformers that are the large language models. That's the architecture for those. I'll talk about that in a moment. But convolutional neural networks, or CNNs, are a part of that deep neural network set, and recurrent neural networks are as well. So transformers are that special model that uses an attention mechanism within the layers to decide on how to apply prioritization, if you will, of the importance of certain terms that are in the inputs to predict the next text that it's going to output. So it's a text generative model. A transformer is, and it's specifically using this attention mechanism, which determines which of the terms in the input sequence are more important than others and have to be considered with higher value than others. Any questions about that?
Yeah, and just to be clear on that, the transformer is kind of and not an antithesis to RNN, but it's a different architecture. Could you explain how attention kind of picks and chooses recurrent is in a sequence, right?
Yeah, a transformer is really all about text generation, and a recurrent neural network is typically used for processing sequences, so time sequences. It basically preserves, a recurrent neural network preserves the state of the previous calculation and then applies that to the next in the sequence. That's not necessary when you're trying to generate text, right? There you're just trying to say semantically, or the mathematical representation of the semantics of the input. Now I want to generate text that's relevant to that and is responsive to some of the directive instructions that are coming through in the prompt.
And I think it's important to note that it might be that, in my understanding, is recurrent neural networks is really how they were analyzing text prior to the transformer paper. And the reason why they didn't get very far with RNN is because of the extreme because it wasn't as diverse, or it wasn't computational heavy. There's a reason why they couldn't go very far with it.
Well, it goes very far for particular applications. For example, a recurrent neural network would be ideal for a time series prediction. So take a really massive amount of data, dump it into a deep neural network that's a recurrent neural network, and it can figure out what all of those various parameters are going to be in the next state, right? In the next step, if you will. So the step sequence.
Okay. So before you go, Keith, because I love where you're going with this, Andy, but I want to take maybe just a branch off of transformers, because you did mention semantic, and I want to just take a brief pause here, super quick, for the math side of this. So let's just talk really quick about vectors and semantic search and tensors, and even what embeddings are. So I'm just going to kind of go off it because I would know all this off the top of my head, but I understand the vector. So that's the mathematical object used to represent words, a vector. People who are listening to this might know vector graphics. That's where I definitely heard of vector first. That's where a picture, an image, is broken down into basically the pixels, but then they're given a mathematical assign some sort of mathematical figure. It's what essentially allows you to take a screenshot of us right now and turn it into a vector image, which would enable us to put this on a large billboard on the side of a road without it getting blurry or distorted along the way. It has to be turned into math. So you could think of vector that way. But we also use vector when it comes to transformers or large language models. So where each dimension corresponds to a feature attribute. So then, Andy, you mentioned semantic search. That's a technique used to find relevant documents or passages based on their semantic meaning, often using vector similarity. Okay, vector similarity. Well, we can start getting into this idea of vector space. We don't have to get too heady here. But if we can imagine to the best of our human brains, a multi-dimensional space, not 2 or 3D, not even 4D, but like 128 dimensional space type idea, or 500, whatever it is. And all these things are moving around in this kind of crazy space. Again, hard to conceptualize because we don't have anything right past 3D, past what we can understand. So All these things get different assigned mathematical values. And then basically using trigonometry, using cosine similarity, measures the similarity between two vectors defined as the cosine of the angle between them, which is kind of crazy to me. So like back when you're thinking about high school and going like, why do I need this trigonometry? Well, it turns out it has a lot to do with how we think about semantic search and how words like dog and cat are similar because they're house pets, but they're also different in a lot of ways because one is a dog and a cat, but then a cat and a lion might also be similar. And so all these things are happening in a vector space. And then we can think of the last one I would say just before we get too heady in this is embeddings. So that's a dense vector representations of words or phrases, typically learned from large data sets and used as an input, bringing us back around to where Andy was with LLMs and the transformer model. So just wanted to throw in the math in there because that's how this stuff is all sort of happening on the back end. And it's important because a lot of people going forward, a lot of businesses are going to want to train on their own data. We already do this. A lot of us already do this with our clients. And they're going to say, I want to train on my own data. And there's some like really fast ways to do it. And then there's some really deep, solid ways to have these models train on the data. And that really does go into how it's using vector space, how it's doing embeddings, how it's doing the semantic search, so that when it goes to retrieve that data as part of the LLM solution, whatever that search result is, that it's high quality data and it can be trusted about your company, about whatever it is that you have it trained on. Okay, I'll stop there.
So let me just clarify that what Brian was just explaining has to do with a vector database. That's a component of a system that would include a generative model that needs inputs that are relevant to the question. And you're not going to capture all of the knowledge necessary or have the right prioritization of knowledge within the pre-training of a GPT, which is an LLM that's a generative pre-trained transformer. So you need to have this external database with your company data, for example. And he's talking about embeddings. That's the way of converting that data into mathematical representations that are then stored in a vector database, which records the directionality and proximity of each of those mathematical representations of the data. And then when you do a search against that database, it's going to find the things that are closest to, in this dimensionality, is closest to the things that you're querying about.
Which is why,
go ahead. Yeah.
Which is why that is so computationally heavy, because the more layers, the more parameters, the more tokens. Come on, give me the word.
Dimensions.
The larger the model,
okay,
the more those connections are.
That's right.
The more parameters. That's the word I was looking for. Right. The more parameters, it exponentially increases in computational bandwidth that is necessary to get those answers, because you start finding the associations of these words in this vector sphere, like, which is think of it as a three-dimensional, right? If you're looking at a recurrent neural network, which is why I can bring this up, it's linear. And so when you start doing the attention mechanism, it's kind of the first part of the sentence, the end of the sentence, in the middle of the sentence, those words are connected together in the vector sphere. And then you're asking for the middle word, what other associations does it have in every other occurrence in the human language of the word cat? And so you're looking, that's where the vector comes into place, because with the attention mechanism, it's attaching itself to every word that has ever been associated with cat in a sentence, not just the one before, which is where RNN comes into play. And so that's why the computational heaviness comes into, is why it's so hard right now, and why all these companies are building $100 billion data centers to compute this, because they're basically basing it on the current science and infrastructure of the transformer mechanism, or the attention mechanism, the transformer paper. But as new technologies come out, as we've talked about on this call, they're hoping to incorporate that linear piece in addition to the transformer piece. I mean, anyway, I just want to be clear on that.
I want to make sure that we maintain the distinction between the vector space that you're describing, which is outboard to the large language model, which is a deep neural network. That vector database is a very different animal, but they're used together. The vector store to deliver inputs for context in the streaming through the deep neural network that generates the output. So
right,
but two pieces.
Vector, yeah, you're right. Vector is completely different. But in order to get to vector, you must start with an embedding, which gives it a numerical number, and then that's
right.
stored in a vector database. So that's what we're talking about: vectors and embedding.
So when you take your company data and you put it into a vector database, the first step is to do embeddings of your data.
Right.
And
right.
That's
So,
what is. And by the way, when you do a retrieval, and that gets us to the retrieval augmented generation process that we're describing here with these two pieces. When you go to retrieval, you have to take your question, the question that you pose to the LLM, you have to go and embed that so that it is comparable and can be compared to the embeddings that are in the vector data store. So now you can bring back all the relevant context data. They're translated out of the embeddings into text again, and then that serves as the input to the large language model.
And so this is a great place to just put a pin real quick and say, okay, why is this important? You know, Robert was saying right before we went live, why is this important? It's important because think about the process that's happening. Think about how complex and crazy are the English language is, and what semantically we might mean by one thing or another. All four of us on this show could generally attempt, if we had a piece of paper and it said explain this concept, more than likely all four of us would come about it a slightly different way. We might use some common terms, but we might come about it at four different angles, all to get to the same result. That's just human language. So the reason I bring this up is because everything you're talking about is exactly what's happening. Embeddings and transferring it and getting it over to the vector side and then back, and then where RAG comes into it, and then where the language model has been pre-trained and all this stuff, which really comes back to say, like, why is this important? Because the better you can get at being very specific about the goals and the tasks that you're trying to accomplish using a chatbot like a ChatGPT or a Meta or any of them right now, the better the responses you're going to get. Because the more you can help the model better understand what it is you're trying to say, what do you mean when you say this thing, the better results you're going to get.
I think it's more important than that. I think it's limitations, because what for me is, if you understand the underlying architecture for how these models work, you're not going to be kind of caught in the hype, right? And more importantly, like, none of us here probably understand the basics of how a computer operates. I don't. Zeros and ones, on, off, all the basics. I took computer science when I was in college, but I've since forgotten actually how a computer works. The bare bones. Like, if I were to go back in time 100 years with the knowledge I have, I could not create a computer. I mean, I just couldn't, right? So my point is,
that's like the Turing test for knowledge. Yeah, that's good.
Yeah.
So you might not. We're not asking for that level of understanding. We're just suggesting that when you understand these basic concepts, you know that the language model, the reason why there's limitations, is because of how they operate. And then you can better strategize solutions for your organization, your company. So it's quite important. Not that you know all the inner workings and how the sausage is made per se, but you do need to understand the different brands of sausage and the different, components of sausage.
Back when Windows came out, way back, Windows 95, no, it didn't probably been before that, 93 or whatever it was. I remember as a teenager, maybe a little younger than that, I'm not sure, just having to understand, I was probably 12 or 13, having to understand the concept of windows and folders, right? Like, how things are categorized underneath places, and just logically, where would it reside if I needed to go find this file? Where would it reside in a Windows infrastructure when I'm looking at the screen? Because we weren't using mouses before that. So now you have to figure out where you're going to go click. And once you have that better understanding of the infrastructure, like the structure of it, you got better at using the computer, because now you say, oh, I understand how that works. I understand like you said, Robert, I love the idea of this. What are the limitations, and how do I protect myself from being disappointed when I get a certain result? And even better than that, if I get a poor result, how do I go back to the prompt and make updates in order to try to get a better result? Because you don't abandon it, you reword it, you give a little bit more context. There's a lot of different ways. Hell, one of the words we could talk about, one of the terms, few shot. Now, you don't need to know what few shot is. It's a weird term. few shot, but a few shot just means the ability to provide an LLM with examples. So forget few shot. It just means give it an example. Hey, I need you to write this email sequence, or well, it's not even a sequence. I need an email, a cold email. This is what I think a cold email looks like. Right? In my best opinion, this is a great example of 3 cold emails. Okay, I need A, B, and C.
Yeah.
Now write me an email.
And zero shot. So there's zero shot. So most of the work that we do with ChatGPT is zero shot. We just ask our question. We don't give it any examples. But it's really important that we're talking about this right now, because one of the best ways to improve the outputs of whatever you're doing is to provide at least one example. Right. And better yet, there's just a new paper that came out this week or in the last 10 days or so, which shows that the more examples you give, the better the result. If you give it 100 examples, that's ratably better. I'm not sure that it's linear or exponential. It's not exponential. It's going to be linear.
I wouldn't have 100 examples.
Significantly better. So shots are really the inoculation of the GPT to get you the better result.
If I can provide 100 examples, I wouldn't need an AI.
Well, that's right. They did note in the paper that this imposes a significant burden on the preparation of data and prompts. So
and I, not the topic of the show, but I would really, I don't know that I would push back on that. I will say that I have not always found that to be the case, and I will just say that. But again, it's probably input user error. It is probably me. I'm more than willing to say that. Maybe my examples weren't like my 100 examples weren't dead on. What I have found that if there is a tipping point for me, usually past 5 examples, where the response for me starts to decrease. Yeah. And I think the reason is because like the way I've always thought about it is I'm starting to confuse the model. I'm starting to confuse it as to what it is I think, and it's looking at the examples and then going, I don't like 2 of these. I can handle 3, 4, or 5. There's starting to be too much differences between the examples, which is why I say the answer is probably 100 examples is probably right, but they have to be the right 100 examples.
Right.
And that goes into it. Yeah. So like we don't need to get heady there, but that's probably the answer.
Let's do a lightning round with Craig's comment. You want to post that and do a lightning round?
Sure.
We can, but I want to make sure we get Jimmy too, you haven't really had much of an opportunity here, Jimmy.
Oh, so. No. I was just reiterating what you were saying there. And the overall goal is to get to zero shot. That's what everybody wants.
Exactly.
Everyone wants to just say, 2 sentences and then the AI figures out everything else that we want. Right. It's all about anticipation there.
Okay,
but, so let's go through with what Greg's saying.
LLM is obviously large language model. Token is, as we talked about on yesterday's call, is a way that the language models splice up the human language. So a token is a fraction, or it could be a whole word, or it could be fractions of a word that they use to splice up and then use that as part of the input and output of the prompt. Weights, could you explain this a little bit more, Andy?
Sure. So when you go through training in the large language model, you feed it a bunch of data and it flows through all the hidden layers in the deep neural network. And as that is done, the computation that is resulting at each neuron within each layer is to determine what the factor is, the mathematical factor or the weight that it's going to pass on when presented with that thing. And there's a concept called learning rate, and you can make those weights change quickly or slow down the rate at which they change with additional training. But refining those weights is the way that you create the ability of that large language model or any deep neural network to make a prediction. And so the weights are the parameters. That's the parameter, right? There's also another one called bias. So the weights and biases are the key parameters in the layers of neurons in the deep neural network that make it possible to do these text predictions.
And so I'll just throw an example, a recent example. Mark Zuckerberg recently, when he announced Llama 3, announced 3 different versions, the third of which is like 400 billion parameters and it's not out yet. And he said it in the video that he released on Facebook and social media that it's still being trained. And one of the things we can probably assume from that is that they're still assigning and adjusting weights as part of that training of that model. It's not ready to be public because it probably would not give us great results. They're still training that large model, and weights are probably part of it. I'll take temperature really quick because it's on there. Temperature is another way of saying creativity. That's it. That's just an easy way to do it. If you're using ChatGPT, you cannot adjust temperature. It's already preset. It's something like 0.7, although I think it's now more variable than it used to be in the past. It used to be like a hard 0.7. All you really need to know is, like, if you go to the playground, which is sort of the sandbox version of using the API, and in many other ways with using API, you can adjust the temperature. And there's some really, really great ways to do that. The example that Rachel Woods gave me when she taught me about temperature a year and a half ago was, if I set it to 0, meaning 0 temperature, meaning 0 creativity, and I say the sky is, and I hit enter, it will say blue. And if I erase blue and I hit enter again, it will say blue. And it will say blue for as many times as I erase and hit enter again. There's no creativity. The sky is blue.
Variation. I think creativity and variation are also kind of so like it's creativity makes variations of that, like
of the answer. Yeah.
You have the answer. Yeah. So it's not that it's being repetitive or it only has one answer. It's just that it doesn't get creative. I guess like it's the only word I can think of.
So it might, like, as you go up and you go towards like 0.7 or whatever it is, 0.1, it's going to start saying, it might say something like the sky is a indigo color of whatever. Like, it's going to come up with an answer because it's going to be predicting the next word. If you hit delete, the chances if you hold the temperature the same of getting the exact same answer are, I don't know if it's impossible. It's not impossible, but I don't know what that percentage is. It's low. So as we move temperature up and the creativity and the variance and the randomness comes into it, now once you go past like 1 to 1.5, at least in my old experiences, it starts giving you almost gibberish. So it's moved past the point where it's helpful anymore. And now you're getting just a random assortment of words that don't really have anything to do with the sky is. So anyway, that's temperature. Please, somebody solve agent. Who wants to take agent? This is probably my biggest pet peeve right now, is the term agent and it being misused.
Okay, I can do it. But go ahead.
Well, I mean, agent to me is very simple. It's basically allowing getting to the point where an AI or a language model specifically can perform autonomous tasks that is given to it by a human. More importantly, though, without direction. So, for example, if I say, book an airline ticket to Bahamas, it can do the steps necessary to accomplish that task. An agent is differently than an assistant. An agent can go out and know that in order to book a ticket, you need to go to delta.com or Expedia. It's going to know to go to a website. It's going to know to book it. It's going to know to ask questions that are going to either need to be answered by the human, or it creates another autonomous agent to answer the question, right? What is the airport? And it has to find out what the airport code is and know what the times are, whatever. So an agent, I guess, autonomous agent is where I kind of go toward. Allows the user to make run request and the AI to be able to accomplish the multiple steps in order to accomplish that task. Andy, where am I different?
That's right. You're on track. And just to refine the distinction between an assistant and an agent, as you said, an agent is operationally autonomous and can act in different environments. An assistant is the LLM itself. It's going to support you in just providing some guidance. So it's assisting you in the human computer interaction. An agent can actually go out and do things on the web and elsewhere if it has, embodiment in robotics.
And I'll just give us a quick shout out. Go back and watch the episode, listen to the episode from April 12th on Hyperwrite. We did a review of Hyperwrite. Part of that, I did a quick demonstration of the closest thing I've seen to an agent, where the actual program, if you will, on my computer takes over my mouse after I give it an instruction and attempts to go and do that across multiple different programs. It opens up Microsoft Word. It might go over to Spotify. It might go to the Chrome or whatever. And it explains itself as it's going. Now, more times than not, it's wrong. which is why this is great to explain right now, that if somebody is selling, this is why this is important. If some company is selling you an AI agent autonomous solution, they are probably lying to you. They're probably stretching the truth significantly. And this is
I
important.
wouldn't say that
What,
you can do
what
it
do we
through
have out there
LangChain.
that's a true agent? What do we have right now?
They've had it for 6 months. It doesn't always operate properly. It doesn't always operate efficiently, but I haven't played with it for 6 months, so they might have gotten better since then. But I originally had played with it and said, do this task, and it would go and I'll watch it work, and it was very, very interesting. But I don't know. There might be people that can develop those at this point, but
And there's a company called Adept that is focused on autonomous agents, and
this
my
is the
guess is that
new.
they have them working very well right now.
This
Yeah,
is
this
the
is
new.
coming, guys. This is
What's it
coming.
called? That's what everybody is looking to accomplish. It was
Right.
first like language models and having a chat bot or whatever. This is the new, gosh, the word I'm trying to look at, the new frontier. There it is.
Yeah,
That's
and
the new
just yesterday, I read that Mark Zuckerberg in an interview was talking about Llama 4 and its use in developing Llama 5 to be perfectly agentic. So Llama 5, when it comes out, they intend that to be an agent, not just an assistant.
And so this is what I would say in this really quick is, and then we'll try to hit the last couple terms here, is if you're a business right now, it's okay to think about, oh, what will happen when a true autonomous agent is available to my company to do things on behalf of the company, so on and so forth. Right now, though, focus on what you can control, and that's going to be a lot more of the assistant, the AI, the human in the loop. Think about the small tasks that you can get off your company or your employee's plate that can be replaced by an LLM, some sort of AI solution to take that off the plate and make things move more efficiently. But assume that there's still going to have to be a human in the loop, because that's where we currently are. Now, 6 months from now, I may have a different answer, but I certainly don't want anybody getting, paying money, especially paying money and then like signing over like a 12-month contract, subscription where you're paying out the whole year in advance for technology that's moving very, very fast. And I've seen this. I've heard people talk about it on calls, and they're spouting the term agent. I will just say, be careful. Just be careful and make sure you fully understand what it is this company is claiming to do for you. Because more than likely, as of April, it's probably not a true autonomous agent.
Yeah, I agree with you, Brian. And I think part of the confusion is that one of the principal ways that LLMs are being employed in enterprise and in small business is as a customer service agent.
Right.
So if they're going to say, we're going to provide you with an AI agent, they may be just simply saying that we're going to create an LLM that's going to work as an assistant to respond to customer inquiries.
Yeah. I know we're on time here. We're out of time, really. The other words on here were like prompt. I think, look, a prompt is what you are putting in as the end user in order to get the response back out of the
assistant.
The assistant. Yes, there you go. Yeah. Do we want to hit? Andy? Do you want to take a shot at prompt injection? We already talked about shot.
Prompt injection is a term that's used to capture a generally nefarious effort to use prompting in modified prompts that are tricking the LLM into revealing information either about itself that shouldn't be disclosed, or to do something that's against its principles as governed by instructions that are provided in the system instructions, the developer of the AI. So you can get it to tell you how to build an napalm bomb, for example. That you would use prompt injection as the way of getting that result out.
Shot, we already talked about. Those are like examples. Markdown, that is a style of writing, if
text
you will.
Formatting. It's basically text formatting. Yeah. And it's also understood that formatting, Markdown, the specific formatting of that, which uses a very specific kind of characters like hash signs and or dashes and so on in particular ways. The AIs understand that structure and know the hierarchy of Markdown. So it's an important thing to learn if you're going to do structured prompts.
Mm-hmm. And I will say this, if you've been messing around with Meta AI like I have, because I'm very impressed with it right now, I asked it straight up, like, Meta, do you work better, more efficiently when people use Markdown? And it said yes. This is the answer from Meta. It helps me better understand the context and what the end goal is, essentially. So there's a lot of value to it. Last one on there is multimodal. That's a great one. Multimodal refers to the use of multiple forms of input and output, such as text, images, audio, video, gestures, to interact with a computer system or AI model. Read that right off the screen, but that's basically what multimodal is. You're seeing a lot more of this. A good example of multimodal would just be using ChatGPT these days. In the past, DALL-E 2 and DALL-E 3 were outside of that. You used a different tool to get images. Nowadays, you can just be in a chat. Meta.ai does the same, and it will just, so does Google, and it will just create images along with text. And so we will see a continuation in this area, which is to say that in short order, you will use one sort of assistant, if you will, and it might be able to respond back to you in voice. It's the sound. It might be able to do images. It could do text. It could do all of them together. It might be able to produce a video and a short summary. So instead of just getting an answer back of here's my question, here's the answer, it might produce a 30-second video with images and talk over, just like you would see on YouTube, explaining the concept back to me. That would be multimodal. So using it going both ways, images going in, images coming out, so on and so forth. Okay. And Greg said, Gemini said no. I think he's referring to probably to Markdown, if I had to guess. That Gemini says no, it doesn't need Markdown. By the way, ChatGPT says the same thing. Meta says it helps. So there you go. All right, we're on time, so we're going to let this go. Hopefully this was helpful. I think when we definitely covered a lot of terms, but more importantly, just understanding the concepts behind it. It will help you when you go to use these tools. It will help you to have better expectations, I think, and managing expectations is a huge part of having success, both yourself and with your team, at your job, at your company. If you're just deploying AI, setting and managing expectations is going to be a huge part of the future success of these AI deployments. So hopefully this is helpful. Tomorrow we'll be back with the news. But until then, we'll see you guys. And thanks for all the great conversations. Thanks, Greg, for the comments as well. Bye, guys.
Aloha.